Okay, so the first triangle that we constructed yesterday together as a class was a perpendicular bisector. And so as we did that, when we were looking at perpendicular bisectors, we saw that the location of the center when it was an acute triangle was, do y'all remember? It was inside the triangle. Very good. Then when it was obtuse, do y'all remember where the center moved? Outside the triangle. Very good. And then when we made the triangle a right triangle, where did the center end up? On the triangle, on the side of the triangle. Okay, and so I looked at some of y'all's sheets and we got different answers for some of them. So we're going to go back through and look at together. Let's look at altitude first, okay? So if we're looking at an altitude and I take this point C and I make it first an acute triangle. So acute is all angles under 90. Are all those angles under 90? So where is it when it's acute? Inside. Okay, let's make it obtuse. So I'm going to take C and drag it so that A is greater than 90. So I'm going to make that angle up there really big. Where'd it go when that happened? Outside. We can't even see it anymore. Okay? Now I want to make it a 90 or a right triangle. So I want to bring C back in to make these perpendicular. And what happens when I make them perpendicular? It's on. So what is it the same as? Perpendicular bisector. So let's go back and fill in altitude. So altitude was exactly the same as the perpendicular bisector. If it was acute, the center was inside the triangle. If it was an obtuse triangle, the center was outside the triangle. And if it was a right triangle, the center was on the triangle. Okay, so next let's look at median. Okay, so for a median, first we're going to do an acute triangle. So all the angles are less than 90. Is this triangle already an acute triangle? Yes, so where is the center when it's acute? Inside. Okay, what about if I take C and drag it and make A a really big angle? Where's the center? It's still inside. Okay, what about if I make it perpendicular, make it a right triangle? So no matter what happens, it's where? Inside of the triangle. So that's what we're going to write. We're going to write for median, always inside the triangle. Okay, and the last one we want to look at is the angle bisector. Okay, so looking at that one, is that a right, acute, or obtuse triangle? It is acute. It's close to right. If you want me to move it, I can make it a little more acute looking. Okay, so where is the center located? Okay, inside the triangle. Now let's make A obtuse by making it a really big angle. Oh wait, I clicked. Oh, it's on altitude. Okay, let's real quick go to GeoGebra and we'll actually do the angle bisector. Okay? All right, so here's the actual angle bisector. So there's an acute triangle. It's inside, right? Let's make it obtuse. Where's the center? Inside. And what about if I make it a right? It's still inside. So angle bisector means always inside. Okay, so really quick, why do you think that perpendicular bisector and altitude end up doing the same thing? What might they have in common? Very good. So perpendicular bisector means 90 degrees. Altitude means 90 degrees. That is what makes the difference. If the angle right here has to be 90, then it moves our center inside and outside and on the triangle. The other two don't have anything to do with right angles. It's just talking about sides or angles being equal. Does that make sense? Okay. All right, so now let's move on to our review. So the first thing that I want to go over in our review are the definitions, because that is what is going to make you most successful tomorrow on your test. You have to know your definitions in order to be able to set up the problems. So, does anybody remember what it's called, or the word that means when a point is the same distance from two or more objects? What do you think, Haley? Okay, it is equidistant. Okay, and so an example of that would be if I was going from A to X, this distance would be exactly the same as from B to X. So I'm going to label these as being the same. Okay, and the only thing that we could use for this is that part would equal part here. Why would 2 times part equals whole not apply? How about because these are 2 different sides of the triangle. So we can't find a whole side of a triangle of 2 different sides of a triangle. Okay, so it's just part equals part. Now, do y'all remember the term for the point where 3 or more lines intersect? Point of what? Point of concurrency. Okay, and so for the picture, all I'm going to do is draw 3 lines intersecting, and then my point where all of them intersect. So that's the point of concurrency. Now, there's not really a way to use that to solve for something, so we'll just leave the how to use blank. Okay? Now, let me finish reading the definition, and then we can answer. A segment that passes through the midpoint of a side of a triangle and it's perpendicular to that side of the triangle. So it has to go to the midpoint and split the side into 2 equal pieces, and it's perpendicular. Which one fits both of those? What? Perpendicular bisector. Okay, So we want to draw all the perpendicular bisectors. Now, before you start drawing, there's a misconception about perpendicular bisectors. Most people think that they have to come from the vertex. They do not, okay? They have to form a right angle, which means it has to be a straight line. If I went from here and drew a straight line, would it actually split these sides into two equal pieces? No, okay? So what we're going to do when we draw our perpendicular bisector, we're going to start at the midpoint of a side and go straight up. So this would be my first perpendicular bisector. Okay, and so that forms a right angle, and it splits these into two equal sides. I'm going to do the same thing here. So I'm going to go to the midpoint and go straight up, or straight out, to form a 90-degree angle and cut these two sides in half. And then I'm going to do the same thing with the third side. I'm going to go to the very middle, and I want to go straight up, or straight out, to form a right angle and to make these sides congruent. Okay, so there's an example of three perpendicular bisectors, right? Okay, now what is a segment that bisects an angle of a triangle? Angle bisector, very good. So an example of an angle bisector is it starts at the vertice and it comes out to make two equal angles. So our angle, remember, is at the vertice, not where it hits the side. So these two angles would be equal. And this threw them, the other class off. They were like, well, why is it part equals part if it's talking about angles? Because when they think of parts, they think of sides. This literally means angle equals angle, okay? Or 2 times the angle equals that whole angle. It's still parts, it's just parts of an angle instead of parts of a side. Okay, questions? Okay.
No question.
Okay, what about a segment whose endpoints are on the vertex of the triangle and the midpoint of the opposite side? So what? A median. So if I was to draw an example of that, I'd have to, it's got to hit the center of this side. So I'm going to go find the midpoint of this, and it has to go to the vertex. And so if it hits the center, that means that this side and this side is congruent. Okay. Next one says it is a perpendicular segment from the vertex to the opposite side. So which one only deals with perpendicular or right angles? Altitude. So this one would be an altitude. So again, this one goes from the vertex straight down to the opposite side. So if I start at the vertex here, that's close enough. So from the vertex straight down, this is what makes the 90-degree angle. Okay, do we remember the point of concurrency that goes with perpendicular bisector? What is that? Circumcenter, very good. Okay, so again, just like the picture above, we want to draw our perpendicular bisectors. So I always start at the midpoint and go straight up from each side. You can draw all your right angles. And equal sides if you want. Here is my circumcenter. Okay, and the definition for the circumcenter, how we would solve things using the circumcenter, is from the points to the vertex is equal. So what is the vertex of a triangle? Where is that located? Okay, where the angles are. So here, here, and here. So it's saying that if I drew a line from the center to the vertex here, from the center to the vertex here, and from the center to the vertex here, that all of these would be the same length. So you want to know that tomorrow. It's going to make some of these problems very, very easy if we know to the vertex is equal. Okay? What about the point of concurrency of the angle bisectors? The incenter. Very good. And so for angle bisectors, we want them to come from the angle out so that makes this angle equal to this angle. This angle is equal to this angle. And this angle is equal to this angle. Okay? Here is my incenter. And then the definition for this is that the points to the sides are equal. So from the center to the side, center to the side, center to the side, all of these should be equal. Okay, what is the point of concurrency of three of the medians? Centroid. The centroid, very good. Okay, and so the median goes from the vertex to the midpoint of the opposite side, so I'm going to actually go backwards. I'm going to go from the midpoint to the vertex on each of them. Okay, now remember, that means this side is equal to this side. This side was split and equal to this side. And these sides are equal. Okay, this is my centroid. And a median median has a long piece, a short piece, and a whole piece when it's being intersected. So what do we know about the long piece and its relationship to the whole? It's 2/3. So I'm going to write here our generic formula. Long piece equals 2/3 of the whole. And what does that mean the short piece equals then? So I'm going to write that too. Short piece equals 1/3 of the whole. Okay, questions so far for this? Okay, and the last one is the point of concurrency of 3 altitudes. What was that called? Orthocenter. Very good. So remember, an altitude goes from the vertex straight down to the side to form a 90-degree angle. So it would come straight down here to form a 90-degree angle. Come straight down here to form a 90-degree angle. And straight down here to form a 90-degree angle. And there is my orthocenter. Now, there's not anything that the orthocenter tells us like 2 lengths are the same or anything is 2/3 of anything else. There's not really a how to use. So we're going to leave that blank as well. Okay? So the first question that you asked about was number 9. And if you don't need number 9 solved, go ahead and work ahead. And as we get to things, if you need help, we can go over those. So for number 9, it gives me that this side, xz, is 57, and then yz is 57. So if these are equal, that means that actually implies that these angles are equal. And if these angles are equal, it implies the bottom is equal. So it asks me to find xy. Xy is this whole length right here. If half of it is 24, the whole thing is 48. No, you're good. That was a good question. Okay. And let's look at 14. Okay, so 14 says up here, given that DB is 18.2, CA is 35.4, and CB is 35.4. Find AD. So they want us to find this. So again, if these are equal, it implies these angles are equal, which implies these bottom pieces are equal. So what would AD be? 18.2. Very good. Okay. And let's look at number 20 next. Okay, so for number 20, it tells me that IJ is a perpendicular bisector. So IJ is this line right here. Now, what does perpendicular mean? Forms a right angle. So where it hits the side, I want to draw right angles. And what does bisector mean? Cuts in half. So this side, where it hits the side, is being cut in half. So that means this has to do with angles. This has to do with sides. So that means we're either going to have to use the sides to solve for x, or we're going to have to use the angles. So the two sides that are cut in half, do we have both of those measures? No. So I actually can't use this. This is a distractor. Does perpendicular bisector tell me anything about the length of IG? No. So that is also a distractor. It doesn't tell me anything. So that means we're going to have to stick with the angles. So which one of these triangles do I have all the angles for? IFJ. Okay, we have that F is 7x. This angle up here is 2x, and this one's 90. So what should all three of those add to be? 180. 7x plus 2x plus 90 should equal 180 because all angles in a triangle add to 180. So I'd combine 7x and 2x, which would give me 9x. I'd subtract 90, which would give me 90. Then I would divide by 9, and x would equal 10. Okay, so that was all your questions 1 through 20. Do we have any questions 20 through 40 for those of you who kind of worked ahead, or if you just want to look at some that you aren't sure on how to start? Yes? 22. Okay, so 22 says WA is an angle bisector. So I'm going to highlight line WA. Okay, so that means that these angles are being bisected. Also, these angles are being bisected. Then the information they give me is RA, this length of this side right here, is 2x plus 9. And then it tells me GA, this length right here, is 5x. Okay? So remember on the first couple problems we did, we said if the angles are congruent, that implies the sides across from them are the same. So that means RA is the same as AG because they're the sides across from the angles. So we would set those equal, and we get 2x plus 9 equals 5x. From there we'd solve for x, so we would subtract 2x from both sides. That gives us 9 equals 3x. Then we would divide both sides by 3, and we get x equals 3. They also asked me for GA, so I would take this 3 and plug it back in where? 5x. So 5 times 3 is 15. Okay, on 21, it tells me that XY is an altitude. So I'm going to highlight XY. Okay, and what does altitude mean? 90 degrees. So I want to make sure when it hits this side that I draw my right angles. Now, does altitude tell me anything about the sides? No. Altitudes only have to do with 90-degree angles. So what is x plus 24 and 3x minus 8? Distractors. Get rid of them. We know nothing about those, okay? It tells me MXY, and I'm going to highlight this so I can see it. So we're looking at angle MXY. So if I go from M to X to Y, it tells me this angle right here is 2x plus 18. Then it tells me that XMY, so if I start at X, I go to M, and I go to Y. I connect these two sides. It's talking about that angle right there is 4x. So what do you think we'd do to solve this? We have an angle, and 90. Add them all together, set them equal to 180 because they're all in the same triangle. So all these angles add up to be 180. So we do 2x plus 18 plus 4x plus 90 equals 180. Combine 2x and 4x, that gives me 6x. Then combine 18 and 90, which gives me 108 equals 180. Then we're just solving for x. So first we would subtract 108. This would give us 6x equals 72. We would then divide by 6, which means x equals 12. Then they asked me to find x, m, y. So I'd go back up here, plug back in. So 4 times 12 gives me 48. Yes, ma'am. Yes. Okay, so 26 says that OJ is an angle bisector. So I'm going to highlight OJ. Now, are my angles that are equal going to be up here at the vertex or on the side? At the vertex. So this angle and this angle, these are equal. Okay, does angle bisector tell me anything about sides? No. So what should I do to 5m and m squared minus 6? Get rid of them. They're just distractors. Okay? So now it tells me DOR. So if I trace DOR, I'm looking at this whole angle right here is x squared minus 32. Then it tells me DOJ. DOJ is actually this angle right here is x squared plus 6x. So what would I do if I'm given a half and a whole or a part and a whole? 2 times part equals whole. So we're going to do 2 times the part, which is x squared plus 6x equals the whole, x squared minus 32. So 2 times x squared is 2x squared, and then 2 times 6x is 12x, and that equals x squared minus 32. Okay, so if we have x squared, what does that mean we're going to have to do? Factor. So if we factor, we have to get everything where? On one side. So I'm going to take this x squared and I'm going to move it to the left and combine it with its like term. So 2x squared minus x squared is just x squared. Then I also want to move 32 over, so I'd add 32 to both sides. Now, can I combine 32 and 12x? No, so I'm going to bring plus 12x here down, and then I'm going to put plus 32. Okay, so what type of factoring is this? Very good. Trinomial shortcut. So I can go ahead and put my parentheses. What letter is going to go in both? X. And then I'm looking for something that multiplies to give me 32 and adds to give me 12. 8m4. Does that work? So positive 8, positive 4, but we want x. So what would x equal if these are both positive? Very good. The opposite, negative 8 and negative 4. Yes. Number 23. Are you wanting number 23 because you're not sure how to factor it, or because you don't know how to set it up?
No, I know how to set it up, but I got to the end and I don't know how to factor it.
Okay, so tell me how you set it up. Since you know a median means these two sides are equal and that the whole length is this length right here. How did you set it up?
I put 2 times 4x squared minus 14 equals 2x squared minus 4.
Okay, so 2 times this part equals the whole. Okay, so we distribute this 2 out. That gives us 8x squared minus 28x equals 2x squared minus 4x. So we know we're going to have to factor, so we get everything on one side. So we would subtract 2x squared. And that becomes 6x squared. I also need to move this 4x over. Since it's being subtracted, I'm going to add 4x to both sides. So then that gets rid of everything on my right. That gives me negative 24x. This is one of the easiest ways to factor. Okay? So there's only 2 ways to factor something with 2 terms. It's either difference of squares, where you take the square root, or it's GCF. So can we take the square root of either of those? No. Do they have something in common? What is it? 6. What else do they have in common? 6x. So all we're left with is x minus 4 in parentheses. What is the x outside of the parentheses always equal to? 0. And what is this x equal to? 4. So we get 0 and 4. And then to find ET, we would plug back into what? Because ET's right here and we don't actually have a length. 4x squared minus 14x. Very good. So if we plug in 0, it's just going to give me 0. If I plug in 4, it's going to give me 4 times 4 squared minus 14 times 4. 4 squared is 16. 16 times 4 is 64. And 14 times 4 is 56. So when you subtract those, you get 8. Yes?
On the test, are there going to be like decimal answers?
No.
No? So they
No.
can all be whole.
Some of them may look like 3 over 2, and you leave it as 3 over 2, but it's not going to be 1.4372. You may get a fraction, but just leave it as a fraction. Yes? 24. It's a perpendicular bisector. So that means 90 degrees and these sides are equal. Okay? And so that actually means that these sides are equal. So you'd set those equal. Okay, no more questions?